So in this video we'll look at the other main way of importing data into R, and that's from a plain text file. Now the file I'm going to import from is this one here, rwm.data.text. So it's a simple text file with a .txt extension. We can have, let's have a look at that. And here it is. As you can see, yeah, it's actually quite a very large data set here, 27,000 plus cases and 25 variables. As you can see, it's simply a plain text file. Obviously it has to be in this table, this spreadsheet format, with the variables in the columns and the cases in the rows. There's no header row here with variable names, so we'll need to add those later. And the actual values on each row or each case are separated by simply spaces, so it's clearly not a CSV file. So in this case we need to use the read.table command. So here I'm going to import this into a data frame called data. So I'm using read.table, 9 brackets here. Of course I have to put the file name in inverted commas. Again, I like to make sure I put the extension here. And in this case, of course, nothing else, because there is no header row, so I don't need to put header equals true. It will use the default value of header equals false. And again, because this file is in the same directory, the same folder as my source editor file, as this file, then I don't need to specify the full path. So I can read this in, and it comes in very quickly. So here we have now my data frame of this data, 25 variables, 27,326 observations on each variable. We can view that, and here it is. Since there was no header row, of course, then it simply labels each variable as v1, v2, v3 and so on. So later on I'll change those to proper variable names. Okay, the first thing I'm going to do now is to subset, to concentrate only on those cases where the date of the observation was 1988. I know that variable 3 is the date here, so I'm going to use the subset command, as I've done before, to restrict to those particular cases, and I'll store that in data 1. So there's my subset. Here's my smaller data frame here. If we have a quick look at that, as you can see, variable 3 is now restricted to 1988. Okay, now I just want to do a quick check on the data to ensure that it has been imported correctly. The chances are that it will have done so, but sometimes you want to check the data. So I happen to know here that if you restrict this data set to 1988, to these 4,483 cases, then 2,170 of them are female and the rest are male. Now the variable which contains gender is variable 2. So if I look at that, you'll see that this is it's already been coded in the sense that a 1 stands for female and a 0 for male. Remember we saw in the previous video that if this had been characters, if this had been M and F, as in the previous video, then when we imported it, R would have automatically converted it to a factor for us, which would have been very useful. Here that doesn't need to happen. So I'm going to concentrate on variable 2 and filter that here so that I'm only looking at values equal to 1. So this here, the thing in brackets here, in normal brackets, returns a vector where the values are restricted to being 1. So it's a subset of that whole variable. And I'm then going to check the length of that. So notice how I've combined two R instructions here, two R commands. I've nested them so that I can first of all run this command in effect to find that particular vector of values and then find the length of that. Now you can combine, you can nest our commands, our instructions in this way, and you're not restricted to just nesting two. I could put something else around the whole of this if necessary. But in general you don't want to nest too deep, otherwise it becomes a rather long and complicated command which is prone to syntax errors and which is difficult to look at later on. So this should return the length of the vector that's returned here, which is just those values equal to 1. And indeed I get 2170, which confirms to me that that I knew that's the number of females in this subset here. So it looks as if everything is fine. Okay, now for the purposes of analysis, I'm not wanting all the 25 variables, just these 6 here. Variable 5, variable 4, and so on. Those I know are the variables I want to concentrate on. So again, I'm going to create another data frame here. I'm not subsetting, well, I'm subsetting here, but I'm not in the sense simply subsetting just based on one condition. I'm choosing these 6 variables. So I'm using the data frame function here to create another data frame just with these vectors, these variables. So that creates my third data frame. It's restricted now to the 6 variables interested in. If I look at that, here are the 6 variables on these 4,483 cases. Again, the names are not particularly useful here. It's just using the ones that I put in the command, so I'm going to now change those to indicate what actually those variables measure, which is here. So using the call names function as we saw before, assign to the column names of this data frame these values as a character vector, and that will of course change the names. And in fact, if you have a quick look back at reg data here, you see that very nicely it's updated that in real time, so that here are the actual values now, the actual variable names. Now, often when you import a data set, before you actually begin your analysis, as well as subsetting, as I've done here, you sometimes want to recode the variables into different values, and that's very easily done here in R. So what I'm first of all going to do is I'm going to take this healthy variable here, which is currently values ranging from 0 to 10, and I'm going to recode it so that any value greater than or equal to 7 gets a 1, is replaced by a 1, and any other value is replaced by a 0. Now notice the command to do this, it's called if-else, which basically explains exactly what it does. It's saying if the value in this variable is greater or equal to 7, turn it into a 1, else give it a 0. So the if-else command here requires 3 arguments: the test, the condition, then the value if the test is true, and then a comma, and then the value if it's not true. And I'm going to then assign these values back into the variable healthy. So I think you can see how I'm doing that there. This is a very useful command for recoding. Of course, you could use this to create a dummy variable. So let me run that command. And if we check again on reg data, as you can see, those are now updated just to 1s and 0s based on that condition. The other recoding I'm going to do is to divide the income values here by 10,000. So again, you can see how I do that. I simply reassign into this variable the values divided by 10,000. Again, if I check back, you'll see those change. So very easy to recode values in the variable Now let's just have a quick look at the structure of the data frame that we've now got. So here we have our data frame with these 4,483 observations on these 6 variables. Here I've recoded healthy and recoded income. So this is all ready now for my analysis. Now let's finally just look at some summary measures, which again you often want to do when you've got your data set ready. So if I use the summary command here, as we've done before, what it does, of course, as we've seen, because a data frame is a matrix, it simply summarizes the data in each column, in each variable. Since they're all numeric variables, some are floating points, some are simply integers, then it gives me this standard information. Notice here I haven't got everything that I might want to look at. I've got the mean, median, quartiles and minimum maximum values. What if I also wanted to know the standard deviation of each variable? Well, we've seen how to do that previously in the matrix video. To act on the columns of a matrix or the columns of a data frame, you of course use this apply function here. So if you remember how we did this, it's apply, then the data frame name, comma, then a 2 if you want to work on the columns, a 1 if you want to work on the rows. So here I'm wanting to find the standard deviation of each variable which are in columns, so number 2, a comma, and then the function or the operation you want to apply. In this case I'm going to find the standard deviation, which is a built-in function, SD. So all I need to put is that. Remember we've seen before how I could use the mean function. Clearly I don't need to use that here because it comes out in the summary command. But standard deviation here, or of course we again saw in the matrix video that you could put your own function into here. So this should give me the standard deviation of each variable, which it does, and it uses the variable name so I know which one is which. So that shows you how to import data from a text file and then subset it, recode, and find some summary statistics.